All right, let's take a look at another example here. I want to find the Maclaurin series for sine of x squared. Now, we just got done saying that sine of x is equal to the sum n equals 0 to infinity of negative 1 to the n, x to the 2m plus 1 over 2m plus 1 factorial. So that's what we figured out sine of x is equal to. So if we take a look at what this converges for, we can confirm very easily that this converges for all x. Well, x squared, isn't that part of all x? So that would then imply that sine of x squared is going to equal the sum n equals 0 to infinity of negative 1 to the n of x squared raised to the 2m plus 1 divided by 2m plus 1 factorial, which is, of course, if I simplify this just a little bit, n equals 0 to infinity of negative 1 to the n. This would be x to the 4n plus 2 over 2m plus 1 factorial. And I'm not going to do it here, but you should probably take a look at this and determine what it converges for to see if this still converges for all x, which it should. But it'd be a good exercise to just quickly go through to see what you've got there. All right, let's see what else we have. Let's show the derivative of sine x is actually equal to cosine of x. Well, once again, we know sine x equals the sum n equals 0 to infinity negative 1 to the n x to the 2m plus 1 over 2m plus 1 factorial. Well, that would imply that the derivative of sine x equals the derivative of all of that, which is equal to the sum n equals 0 to infinity of the derivative of negative 1 to the n x to the 2m plus 1 over 2m plus 1 factorial. Remember, we take derivatives piece by piece. So this is going to be equal to the sum n equals 0 to infinity negative 1 to the n. So I have 2m plus 1 times x to the 2n over 2m plus 1 factorial. Well, the 2m plus 1 is going to cancel with the 2m plus 1 factorial and give me simply 2n factorial. So this equals the sum n equals 0 to infinity of negative 1 to the n x to the 2n over 2n factorial. Sorry, I should put parens there. This is actually the Maclaurin series for, you guessed it, cosine of x. So the derivative of sine x really is cosine of x when we use the power series to prove it. Okay, find the Maclaurin series for x squared times sine x. Well, I think you probably see, we know that sine x equals the sum n equals 0 to infinity negative 1 to the n x to the 2m plus 1 over 2m plus 1 factorial. But remember, this converges for all x. That would then imply that x squared times sine x equals x squared times the sum n equals 0 to infinity negative 1 to the n x to the 2m plus 1 over 2m plus 1 factorial, which is equal to the sum n equals 0 to infinity negative 1 to the n x to the 2n plus 1 plus 2, that's my 2 right there, divided by 2n plus 1 factorial. And I will rewrite this just one more time, although I'm sure you can see right away where I'm going with this, or where it's going to be. Negative 1 to the n times x to the 2m plus 3 over 2m plus 1 factorial. That's it.